Welcome to the RIPE Labs podcast. I'm Alan Davies, the RIPE Labs editor. 12 years ago, the RIPE NCC set out to build the largest internet measurements platform ever made. Today, with over 11,000 vantage points or probes distributed across the world, RIPE Atlas gives network operators and internet researchers an unprecedented view of the state of the internet in real time. One person who knows more about the inner workings of RIPE Atlas than anyone else is Robert Kisteleki, Manager of Research and Development at the RIPE NCC. We met up to talk about how RIPE Atlas works, how it got started, and the benefits it brings to the technical community. Hello, Robert. Thanks for joining us today.
Glad to be here.
In your own words, as one of the people who was really with RIPE Atlas right from the start, what is RIPE Atlas? How does it work?
I guess the shortest way to say it is it's an active internet measurement platform.
Mm-hmm.
It's, of course, a lot more than that because it incorporates collaboration with the community. It was built by the RIPE NCC. It's distributed. It's all over the internet. It has open data. We basically imagined that there is a need to have enough vantage points and eyeballs all over the internet if you really want to observe internet events.
Yeah.
How the internet works, if there are problems with that, where are those problems?
Mm-hmm.
If you have vantage points or sources of network measurements, if you will, only in a couple of places, then you will probably miss most of the action out.
Yeah.
So what we set out was to have a network where there are active agents all over the internet that are controllable by us and the community, and they do these kind of measurements.
Okay.
Some of these triggers were coming from network operators. We have seen questions on Nanog and other mailing lists and all over the internet saying, I think there is an issue between this part and that part. Can someone please trace route me from those sources to those destinations? Those people who are there, can you please help us? And these questions just came up again and again and again. And that made us think, maybe there's a better way of doing this. Maybe there's a more scalable way of doing this.
Okay. So these vantage points are just points that you send out there into the world and have people plug them into their routers, right?
Yep, their home networks, their business, their IXP, to basically any point on the internet that acts as an endpoint.
Okay. And these devices are the RIPE Atlas probes. So you've got all these probes out there, but what are they actually measuring?
The RIPE NCC and our community is mostly interested in how the network behaves.
Okay.
So what we were aiming for is mostly, not exclusively, but mostly network level measurements. And what we mean by that is that the devices at the moment are capable of doing pings, trace routes, DNS queries, and some other low level questions like NTP. We are able to fetch TLS certificates. And we ventured a bit into doing somewhat more higher level like HTTP measurements.
Okay.
But those are, let's call them experimental at the moment.
Okay.
What we're trying to focus on is the network level.
In terms of the actual infrastructure behind RIPE Atlas, when that probe sends out a ping measurement, how does that work? What's between RIPE NCC and the probe?
So when you take home one of these probes and you say, I'd like to participate, the only thing we really ask you is to plug in the probe, give it power over USB, and give it an Ethernet connection on a network that has, local DHCP and so on. What the probe really does is, as soon as it's powered up, it tries to reach out to the infrastructure that the RIPE NCC built.
Okay.
It basically connects to our command and control servers, if you will, to say, hi, here I am. I'd like to participate. What should I do now?
Right, okay.
At that moment, we basically supply the set of what we call built-in measurements, tell the probe, please start doing these, and you're good to go. What happens then is that the probe dutifully starts executing those measurements, so sends out pings and trace route and DNS queries and so on, buffers up the results for a minute or so, and then supplies the results back to the network.
Okay.
Those results then make their way via the infrastructure to a big data backend at the moment that's based in-house and built on Hadoop and HBase.
Okay.
where we store it, index it, and make it available to users. Now, here comes the fun part where we are entering the user-defined measurement side, where the probe is really useful if it also does things that the community wants it to do, or individual users in the community want to do.
Yeah.
So what happens there is that, suppose you want to do a measurement, say, trace route from 100 different countries to facebook.com.
Yeah, okay.
You can actually do that via the network. What you need to do is you go to the website, and assuming you have credits in order to do this, so for example, you run your own probe or Looker, you go to the website, and either in the UI or through the API, you basically say, this is the measurement that I would like to expect. These are my sources, this is the destination, this is the type of measurement, this is the frequency of the measurement of what I want, and some other properties that you can do. The system takes this and said, thank you, I'll schedule it on probes. Then there is a whole mechanism behind the scenes where what we call a worker component kicks in and says, okay, I was asked to schedule this measurement, let me look for probes. The system does the scheduling, finds the number of probes with the distribution, with the preferred distribution that you want, and sends out this measurement command to all of them.
Right, okay.
So they basically almost immediately pick up this and start doing the measurement. But the benefit of the network really is that any user in the network, anyone who is participating, who is contributing to the network by plugging in a probe, for example, can do their own measurements. And that includes the use of any probe on the network. So at the moment, we have about 11,000, a bit more than 11,000 devices out there. And if you would like to measure something, you can pick any one of those and execute your ping or trace route or DNS query from that location. The real benefit for the community also comes from the fact that this data is then open. We make all of these measurements results available to all the users, which makes researchers very happy.
Yeah, we'll come to that in a minute, actually. I have some questions about the kind of research being done on the back of this. But before we go into that, like, just for the people who are less familiar with RIPE Atlas, who might not have used it yet, even though they could be using it, how do people actually interact with RIPE Atlas? How do you get started with it?
So it's very simple. Let's assume that you heard about it and you're interested in what it can do, and you would like to install, you would like to participate in this network. What you can do is you can immediately go to the website and just check it out what it is. The data is open. The maps and graphs that we produce are also open. Most of the probes are marked as public probes, which means that you can look at the graphs that they produce based on the data that they collect. But then you have a problem that you want to solve. You want to do your own measurements. That's kind of also possible. That's the point of the network. In order to do that, you have to have something that we call credits. It's basically a metric or an exchange of value, if you will, so that you can only use this network if you also contribute back to the network.
Okay.
And you can do that by, for example, installing a probe. How you do that? Basically, you go to the website and you say, I would like to participate. I'm in this network location. Can I have a probe, please?
Okay.
So back in the days when we started with hardware probes, this was the only way of going about it. You had to say, I'm willing to host a probe. There is some set of conditions that have to check that I understand what this means. And then we basically shipped you a probe. Recently, in the last couple of years, we also introduced what we call the software probes, which is basically the same device, except without the hardware.
Right.
So you can install it as a Docker image or just a Debian package or a Red Hat package on your own machine.
Okay.
Maybe even your Raspberry Pi if you have it lying around. So we no longer need to ship the physical hardware device to you. We try to make the hardware probes basically plug and play, or plug and play and forget, if you will.
Yeah.
Which sometimes surprises people as well. Like, oh, I forgot about this device, but it's still there. It's still doing its thing. There is a technical difference in terms of the simplicity, if you will. The hardware devices, you just plug them in. They do a DHCP, they do IPv4, IPv6 out of the box. With the software probes, of course, as you say, there is a bit more involvement.
Yeah.
You kind of have to know how to install a package. What does that mean? And then also the burden of upgrade is on you,
Yes,
because of
okay.
course we are not able to remotely upgrade software on your computers. Whereas with the hardware devices, we are able to push out new firmware just like with any other IoT device. And we do that regularly. So once or twice or 3 times a year, we have new features, bug fixes, and so on that the hardware pros automatically pick up.
Software probes have really taken off, right? The technical community is setting these things up.
Yes, they became popular also because they are easy to install in areas where hardware probes are difficult to get to. We have some logistical challenges shipping to particular countries, as you can imagine, and especially in those cases, it's just very simple as a workaround or just even a permanent solution that people living there or having networks there and wanting to participate in RIPE Atlas can, without our active support, logistical support, if you will. From the functional point of view, the software probes and the hardware probes are exactly the same.
Obviously, the more of these things you have out there, the more vantage points you have, the more accurate a picture you have of the kind of state of the internet, if you like. So what are you aiming at here in terms of coverage? And are you there, or is this an ongoing task of trying to...
When we set out to prototype and then eventually productize RIPE Atlas, about 11, 12 years ago, the internet, as we knew it back then, had about 30,000 AS numbers, ASNs connected to it. So we had this thought experiment: what would it take to have a network of probes or measurement devices to cover this?
Yeah.
And obviously, well, ideally you have one device in all of these networks. But for redundancy, it's nicer to have 2 or 3, right? So that gave us a ballpark number of, well, maybe we should have 100,000 devices. So we looked at, how do we do the architecture in order to support this, and maybe more. Of course, that's a bit naive way of going about it. It's just never going to happen that we'll have 3 devices properly placed in all of the networks. But it gave us a goal. So we set out to build an infrastructure and build the devices such that it can support this if it needed to be. In fact, the infrastructure can, at least in theory, scale up to way bigger numbers. That's how it's built. And of course, we knew back in the day that we're just not going to reach these 100,000. Also, networks are just not the same. There are bigger networks, there are smaller networks. So it just makes sense to have more probes in bigger networks and less probes in smaller networks. What we really imagined is, wouldn't it be nice to have the network with such a deployment that it kind of reflects where the network is, where people are, where the infrastructure is. So have more probes, more devices in places where there is more internet, so to speak. We did not have a specific number of networks we wanted to cover. What we wanted to achieve is to have a good enough coverage for what the network is, for the internet is present. So these probes basically naturally evolved to be in places where the networking people are. They were the first ones to install the probes. And eventually the user base has grown out from the networking staff to individual users even who see benefit in somehow supporting the network, or they get benefits themselves. We do have presence in basically all the major networks all over the world, and a whole lot of smaller ones. I think percentage-wise, we cover something like 5% or so of the IPv4 connected ASs and 10 or so % of the IPv6 networks as well.
Right, okay.
So, of course, this is not 100%, but it is a really good state of the network. The question of whether we ever want to be in all the networks pops up every now and then. But you can imagine that covering all the tiniest networks in the remote places is probably not that useful for the whole networking community. Instead, let's assume that you have a transit provider who has 1,000 small networks as clients. It's most of the time good enough to cover that transit provider. Of course, we have some networks which, for the purposes of the internet measurements, are saturated with RIPE Atlas probes. So some of the big providers like Deutsche Telekom or Comcast, can always install more probes, but the value of the data that they provide is smaller.
Yeah.
That way. In fact, we have kind of a hit list, if you will, per country. We are using data from our friends at Ep.3, who have a good data set about how big network providers are in particular countries. And based on this set, we are looking at what are the big providers all over the world where we do not have presence in. So we are using this as a guidance nowadays because it's useful to, now the network is big enough such that our goal, instead of having more and more and more probes, has shifted to more and more and more coverage.
I don't know if you saw, we ran a RIPE Labs article competition recently. It's the first time we tried this out. And the winner is Pavlos. He wrote a paper on, him and his colleagues are actually working on a research project about bias in internet measurement infrastructures. How helpful do you think this kind of research is for making sure that the kind of measurement results we get from Atlas are accurate and give us a realistic picture of the state of the internet?
That's a very good question. I read the article, and what I found really useful is that they have a definition of bias, what they call bias, and then looked at the distribution of probes, and I think they also looked at risks to see if, for that definition, this system is biased. And of course, you can argue over whether that definition of bias is a good one or not. That really depends on your perspective. But it's certainly true that RIPE Atlas has more probes in some networks. It is also true that the number of probes usually correlates with the size of the network.
Okay, yeah.
So I guess depending on your expectation, when you actually want to run a measurement, what is your realistic expectation when you want to run a measurement with 1,000 probes? Should that be proportional to the number of networks out there, or should that be proportional to the size of the network?
Okay.
Or to the number of eyeballs on those networks? So it is certainly true that if you just ask the system naively, give me 100 probes or 1,000 probes to do this measurement for me, ping that particular device or target, then the network will give you more probes in bigger networks. If that's not what you want, you have full influence over which probes are scheduled in that measurement. So there are ways for you to actually say, I would like to have this many in this region, that many in that region.
Okay.
So you can have an influence in this. In the extreme case, you could even ask for a single probe per network as a source for your measurements. So it is true that to that definition, the network is biased. But we would like to think that that's actually not necessarily a problem. Probably more measurements will be done from those networks.
Okay.
But if you have a different preference, then you yourself, when you want to do your measurements, you can say, okay, what I would like is these set of probes for reasons.
And then there's 11,000 or so probes out there. And how many measurements, say, per day? Roughly, if you know off the top of your head, or we can check the But like, I mean, this is big numbers, right? There's a lot of.
So across the whole network, we are collecting about 1 billion results per day.
Wow.
So that translates to something like 15,000 a second. So these are individual results coming from measurements and coming from individual probes. The total number of measurements running across the system at any given point is something like 20,000 or so, including the ones that are pre-scheduled and the UDMs or so.
Yeah, okay.
But it's also true that not all of the measurements are running on all the probes.
Yes.
Of course, smaller measurements that say, please ping this target with 10 probes are only scheduled on those 10 probes.
Okay. So there really is a whole community behind this. And there's been a lot of enthusiasm in that community, and RIPE Atlas has really grown thanks to the willingness of people to plug these devices in and take them around the world and give them out. So that, who are the people doing this? So there's like ambassadors, sponsors, there's whole different classes of people involved in this community,
yes,
right?
There are a number of actors here. At the very beginning, we reached the network operators. So when we pitched the idea, it was a RIPE meeting in 2010, November, in Rome. We knew that the interested parties are going to be network operators.
Yeah.
Those were the people there at the meeting, and those were the target audience, so to speak, as well. So they were the first people to get the probe, go home and install it in their own home or their ISP or their own network. But eventually, you run out of network operators, of course. So we saturated that probably. We're also still reaching out to other regions, of course. So in the Aryan and Lacnic and Apenic regions, there is more network operators who could get involved. By spreading the word, we're involving them. But eventually, we are shifting towards regular internet users as well. The challenge there is to find the benefit for the common internet users, so to speak, not the network-operated one, to take some of these devices and plug them into networks where we would like to be. But there are other actors. So the ambassadors, as you mentioned, they are the ones who help us reaching regional communities or local communities. We have them all over the world. Something like 100 or 150 ambassadors are actually active to a certain degree. And what they do is that they take a couple of probes or the concept of RIPE Atlas just sometimes, and then convince the local networking people or the local interested parties to join the network. Of course, with the introduction of software probes, that's a bit different. They no longer have to physically hand over a device. They can also just spread the word, evangelize, if you will. That works really well. And it really, really helped us to reach otherwise difficult to reach networks. Of course, the RIR partners and others, industry partners are helpful as well. There are just some providers who like the idea and they would want to help distributing the probes. And they do. And a different level of this is when a provider or an interested party, they can just step up and say, we would like to sponsor this thing. It was quite fascinating to see this happen when people said, how can we help? Can we give you money? And as the RIPE NCC, we're a non-profit organization, we don't want to sell these things.
Of course.
But at the same time, at the moment, the membership is basically funding the project. So when the concept of sponsorship was introduced, we said this is actually a nice way of supplementing it. So the community, the RIPE NCC membership, does not have to bear all the load. Over time, what we did, we developed this sponsorship program where if you are an entity who believes in this and say, I like this, I think it should go on, I would like to support you, then we take that as sponsorship and basically buy physical probes from it, from that sponsorship money, so that the membership doesn't have to cover the cost of the hardware. We're still talking about an infrastructure and people behind it, so all the costs are not covered by the sponsorship model, but it's very important. And then we talked about the hosts. Those are the ones who plug in the probes. And there are also other people who say, well, we would like to have something proper device that we can plug into our network. And we have these racks over here. So do you have a rack-mounted version of your probe? We thought about this and said, sure, we can do that. That's not necessarily a problem. And this gave birth to what we call the RIPE Atlas anchors. Now, the anchors are basically big Atlas probes. So they're way more capable. Of course, you can imagine that a home router or a travel device does not have that capacity as a rack-mounted PC does. So in theory, they can do more. But what we said is that, okay, these are then capable devices, and you want to plug them in basically to the core of the network, if you will. So we attached a server functionality to this. So the RIPE Atlas anchors not only serve as probes or vantage points in the network, but also as willing targets for measurements. So all anchors have publicly known names, and they are providing some very basic functionality. So there's a dummy DNS server on them. They have their own IP stack running. They have a very primitive HTTP server. So they are willing to be targets of these measurements. And this is quite useful for people who run networks, because sometimes what they really want is for their measurement, for their network to be measured from the outside. Get that as a signal of how their network is seen by the world.
So, like, over the years, we've had lots and lots of articles on RIPE Labs about all the research that's been done on the back of RIPE Atlas, on the back of the data that you make publicly available. What are some of your favorite examples of, the research projects that you've seen over the years?
There are so many. I don't know if I can name all of my favorites. But various researchers looked at the data set and tried to figure out what is the value from their perspective in this data set. I do recall a case where people looked at, okay, maybe there are some disconnections from the probes and then reconnections. So what they saw was a definite signal in the behavior of the probe, periodic disconnections and connections, which is also part of the open data set.
Okay.
Right? This is kind of a metadata. So some people looked at where is this happening? Why is this happening? How prevalent is this?
Okay.
Other people are using it to actually observe BGP behavior, for example.
Right.
We are collaborating with the peering testbed where they announce various prefixes in BGP with some attributes by researchers. And RIPE Atlas is constantly monitoring those prefixes to see if they are visible, what is their behavior.
Nice.
So it gives these researchers a completely different perspective of what they see, what they think they see.
Yeah.
Sometimes it's a confirmation, sometimes it's a
Sure.
denial.
Yeah.
But at the minimum, it is a network behavior that we can observe. Of course, researchers are always interested in network events, especially disconnection events. So sometimes, unfortunately, we see that countries disconnect from the internet for political reasons or other reasons. And if we have probes in those countries or close to those countries, we can actually see how this goes down.
Okay.
What's interesting is that our devices, the RIPE Atlas probes, also keep on measuring if they are disconnected from the internet. So imagine that you have a network which suddenly disconnects from the internet. The probes inside that network still try to do their measurements. So they will try to get out on that network, but they fail, of course, because of the disconnection. But they still collect this data about how the network was seen from the inside. Now, when connectivity is restored, and in almost all of the cases, eventually this happens, they supply this data to us.
Okay.
Even for the time period where they were disconnected. And that's quite unique. Other networks that are used for internet measurements do not necessarily have this capability.
Right.
So to see the events from the inside, if you will.
There's all these research projects going on out there, outside the RIPE NCC, that are using this data in lots of interesting ways. But what are we doing internally with this data? What kind of tools and services are we?
We use this data ourselves to analyze network outages.
Okay.
Almost all the time. So there are always some network outages, large and small, sometimes very prominent, sometimes not. And our own internal researchers are looking at this data. Every time we believe that there is a signal, they are looking at the data and trying to see that signal.
Yeah.
And of course, with so many data points flying in every day, that's not always easy. But usually there is an external signal that says, oh, this event happened. Then we can look at the data. What we're trying to do is reverse that and have some kind of algorithm, maybe machine learning, that tries to look at this haystack all the time and say, oh, I found a needle that you didn't know about. Did you know that there is a needle? And so have this in a way where the system actually provides us the signal instead of us having to look into the data and find the signal.
Okay.
But in other cases, we are also using this data to supply other services. For example, we are producing country reports and regional reports where the state of the internet in that country or in that region is what it is, and Atlas can illustrate that to find paths, to find the local providers, the behavior, and so on and so forth.
Yeah.
We're also using this data to feed other systems that we provide. For example, RIPE IP Map, which is our infrastructure geolocation service. And you can imagine that enough trace routes or other kinds of measurements can be really, really helpful to know if particular network components are close to each other or not.
Right, okay. From everything that you've told me today, this is a huge technical and logistical effort. So in your words, again, as one of the people who really brought this into being, why do we do RIPE Atlas?
There are all kinds of events happening on the internet.
Mm-hmm.
And unless you have enough eyes all over the internet, vantage points, if you will,
Yeah.
you will not see most of them. Yet they happen. So every time there is an issue with a network provider or a country,
Yeah.
or just some weirdness in routing, it's really, really useful to have data that can actually explain that phenomenon or help you debug or fix that problem.
Yeah.
What we noticed around 2007 or 8 was that there is basically no good internet measurement network that people can use, anyone can use, to look into these kind of problems.
Just the other day, I came across an article from Dataplane that refers to Atlas as the most extensive distributed monitoring platform out there right now. So it's really, but it was interesting in the article to see that there are a number of other platforms out there today run by other organizations, some of them commercial organizations. So the thought that occurred to me when I saw this, since the RIPE NCC is first and foremost, a regional internet registry, why do we do RIPE Atlas?
The RIPE NCC was indeed formed first and foremost as the regional internet registry in Europe and surroundings. But right from the start, it was in the activity plan that we also want to supply data and other services to the community that we serve.
Okay.
So that includes training and meetings and all kinds of other services. We run KRoot, one of the root DNS instances. We run RIS to collect BGP data. So it does fit into our purpose to have these kind of measurement network. The benefit that the RIPE NCC can provide here is stability.
Okay.
We have seen a number of measurement networks that have been built in universities that were really, really nice while they lasted. But many times researchers build these networks and then they get their PhD, they move on, and those networks usually dwindle and die. Of course, there are also commercial providers.
Yeah.
But our approach was that an open network with open data, with community collaboration and involvement is probably a better idea. You can always turn to a network provider that as a commercial, if you want, but RIPE Atlas is likely here to stay to help the network operators. We are also a neutral party. We do not have reasons to bias the measurements or the results in any way, which is also useful to have the open data for. So you can also trust the measurements that we do in this aspect.
After 12 years of doing it this way, would you have maybe done it another way? Would it be something different from RIPE Atlas if you were starting from the start again? That's kind of a tricky question. It's obviously evolved a lot. But is RIPE Atlas still the best way of achieving what you're trying to achieve?
I think the strategy that we chose in terms of how to distribute this network, how to make sure that we have vantage points all over the internet, and in particular involving the community in that, having those probes, devices installed by community members was the right one. That is definitely something that I would not change. I think one of the values that the RIPE Atlas network provides is coming from that it is a community-based network. Of course, the RIPE NCC is there to provide the whole infrastructure behind it and the devices and the logistics, but we couldn't do this without the community.
Okay.
From the community perspective, that was the right choice. From the technical perspective, evolution happened. We replaced the first generation devices with second, third, and now we are coming up to the fifth generation with software probes, with RIPE Atlas anchors. So that evolution is there. But what we wanted to emphasize that this is not just a RIPE NCC service. It can only exist, and the benefits can be realized if the community is behind it, which it is, I have to say.
Thank you very much, Robert, for talking to me today.
Thank you.